All right, in this video, we're going to look at simplifying square roots with fractions. Only in this video, we're going to focus on imaginary numbers. The last video we did was simplifying square roots with fractions. We focused on real numbers, and in this one, we're going to focus on those imaginary numbers. Some things are the same. You remember the definition of rationalize that I had you guys write down before. Rationalize is the process of removing the radical from the denominator of a fraction. So look at this one. Here's an imaginary denominator, but I don't see a radical. Remember, radical is a square root or a cube root or something like that. And if you look at this one, you don't see anything. But you have to remember the definition of I. Remember we talked about that I is equal to the square root of -1. So this I right here is like a radical in disguise. It's like a -1 square root that's hiding from us. And that's what we have to get rid of. This I in the denominator is causing us some problems. So let's think about how we're going to get rid of that. Well, if we remember from before that I equals -1, if I square both sides, then I squared is equal to the square root of -1 squared. And remember we said that square and square root are opposites. They cancel each other out. And so what we're going to have left is a -1. Now look, that does not have a radical on it anymore. There's no square root. There's no I to be a hidden square root. It's just a regular integer. So what we're going to need to do is we're going to get rid of that I by multiplying by another I, because I times I is I squared, which is -1. So that's the process we're going to go through. Okay, let's look at one so you can see how this compares to a real square root like what we did before. All right, so let's do this one first because it's similar to what we did before. I can see the radical right here in the denominator. That's a problem. I'm not supposed to have a radical in the denominator. So if you remember, we multiplied by square root of 7 over square root of 7. Okay, and the reason we did that, try to remember how many 7s do we need in a circle to come out of the square root? Right, we need 2. So now I have 2. 1, 2. Square root of 7 times square root of 7, that is going to work out to give me a number with no radical. All right, in the numerator, remember this one is outside the square root. This one is inside the square root. So they can't interact with one another. We just write them both down. 5 square root of 7. And then in the denominator, well, that 2 is outside. Both the 7s are inside, so I can't do anything with the 2. And remember, when there's nothing written right here in between the 2 and the square root of 7, that implies that we've got some multiplication there. All right, so now we have square root of 7 times the square root of 7. And square root of 7 times square root of 7, that's the square root of 7 squared, which is going to just work out to be 7. Or you can think about that as square root of 7 times square root of 7 is the square root of 49. Square root of 49 is also 7. So either way, you get to a 7 right there. And that multiplication that was right there, I just brought that down. So 5 square root of 7 in the numerator. And then in the denominator, 2 times 7 is 14. And then we always want to look and see if there's anything we can cancel. So the 5 and the 14 are both outside the square root, but nothing cancels. 7 is the only thing on the inside. And remember, we cannot cancel the 7 and the 14 because the 7 is inside a square root and the 14 is out. So that is our final answer. It's rationalized. There's no square root in the denominator. Okay, so let's compare that with this one. The only thing I've done is I have replaced the square root of 7 with an I, but you're going to see how very similar this process is. So if I want to get rid of that I, remember I need an I squared. So I'm going to multiply by I because I times I is I squared. So in the numerator, 5 times I, 5I. And in the denominator, I've got that 2. And then I remember from before that I times I is I squared. And I remember that I squared equals -1. So I'm going to multiply by -1. So in the numerator, I've got 5I. In the denominator, I've got -2. All right, now books are never going to leave that negative in the denominator. It really doesn't matter, but they're either going to put it in the front like this, or they're going to put it in the numerator, but they never leave a negative in the denominator. You guys remember your positive and negative rules from 7th grade. A positive divided by a negative is a negative, and a negative divided by a positive is a negative. So really, mathematically, it doesn't matter, and I will accept any of these three answers. But if you see something on standardized test, or if it's a multiple choice question, they're not ever going to leave this one. They'll leave one of these two. Okay, let's try another one. All right, let's look at this one. Okay, so I can't have that square root in the denominator, right? Remember that I is a square root in disguise. So to get rid of it, I'm going to multiply by I over I. Okay, now in the numerator, I'm going to end up with 4I. And in the denominator, I've got 3I squared. But I remember I squared is equal to -1. So I can just replace that 4I in the numerator, 3 times -1 in the denominator. So I get 4I over -3, which I know is the same thing as -4I over 3 with the negative in the front, or -4I over 3 with the negative on the 4. And any of those three answers I will accept as correct, but this is the one that's not going to be on a standardized test. Okay, that's all there is to it. You just multiply by I over I every time.